In this video, we're going to be writing the equation of a hyperbola. Now, a reminder that a standard form of the equation of a hyperbola at vertex HK is going to look like this. You've got, if it's a horizontal, the x stuff is listed first, x minus h squared over a squared. Reminder that a squared is always under the first term, minus y minus k squared over b squared is equal to 1. And your vertical, the y stuff is listed first, and it's y minus k squared over a squared minus x minus h squared over b squared is equal to 1. So a reminder that a good way of looking at this, the transverse axis. Again, the transverse axis is the axis that passes through the vertices. If the transverse axis is horizontal, then it's going to be as it is in number 2 here. Here's your transverse axis. If the transverse axis is a horizontal line, then this is going to be a horizontal hyperbola. If the transverse axis is vertical, then this is going to be a vertical hyperbola. So you can look at the transverse axis and tell whether you need to list the x first or the y first. Now, again, with the a squareds and b squareds, now in an ellipse, a squared was always bigger. In a hyperbola, that is not always the case. Let's see, let's go through these. Okay, HK is the center of the hyperbola. A is going to be the distance from the center, just as it is with a ellipse. A is the distance from the center to the vertex or vertices. And that will be a positive a to one, a negative a to the other. And then b is the distance from the center to the co-vertices. So let's try to work one of these problems. Problem number 1, if we're given a graph. Now, first off, we need to determine if it's a horizontal or if it's a vertical. Notice here that this line is vertical, so therefore this would be a vertical hyperbola, so the y stuff is going to be listed first. So you're going to have the y stuff squared over whatever minus the x stuff squared over whatever is equal to 1. That's going to be the basic form. To find what goes with the x's and y's, we'll check the translation here. Here's the center, so therefore and you can find that by looking at your two vertices in this case. Whatever's in the middle of those two vertices is going to be the center of your hyperbola. Or you can look at the box. You can see the little box right here. The very middle of that box is going to be the center. Since the center here is 0, 0, then this has not been translated any. So we could actually take away these parentheses. We're not going to have to do plus or minus any numbers. We're just going to have a plain y squared on top and a plain x squared on top. It's not been translated. Next up, we need an a value and a b value. An a value is the distance from the center to the vertex. Here your a value is 1. The b value is the distance from the center to your co-vertices. And here are your two co-vertices. That'd be a distance of 1, 2, 3, 4. So therefore, since we have our a values and our b values, then we're done. Our a value goes under the first term, so that'd be 1 squared. Our b value will be 4 squared, and it'll go under the x values there. So y squared over 1 minus x squared over 16 equals 1. And if it's over 1, of course, we don't have to put it. So there is your hyperbola. Next up, this is going to be a horizontal hyperbola. So therefore, we're going to have our x stuff listed first. So you're going to have x stuff squared over a squared minus y stuff squared over b squared equals 1. Let's go ahead and see where our center's at. The middle of our two vertices are right there. And that's going to be a center at, here's our origin, 1, 2, 3, 4, 5, negative 2 is our center. So let me write that. 5, negative 2 center. So therefore, we've got to take and we're listing our x's first. Got to take our x values and move them right 5. We got to take our y values and move them down 2. And that's how we do it with transformations. Now all we need is a values and b values. A is the distance from the center to a vertex. So that's going to be 1, 2, 3. So underneath my x's, I've got 3 squared, which is 9, because, again, my A value is 3. My B value is the distance from the center to this co-vertex up here, and that'd be 1, 2, 3, 4, 5, 6, 7. So therefore, under my y stuff, I'm going to put b squared, which is 49. And you do see there an example of, I told you that a, when we're dealing with hyperbolas, are not always the biggest values. In this case, our b was a bigger value. Actually, in both cases so far, b has been the bigger value. Next up, what do we do if we're given vertices, co-vertices, and foci? Here's your steps. Step number 1, always find your center. Use the midpoint formula with vertices or co-vertices. Find out the point that's in the middle. Next, we're going to use the vertices to find A. We're going to use the co-vertices to find B. If we're given the foci, we can use our formula again, a squared plus b squared equals c squared, to find our any missing point. We do have to determine the direction of the hyperbola so we can write our equation. Okay, number 3. We're given vertices and co-vertices. So this process is going to be very similar to what we did with our an ellipse. The only difference, well, there's not much of a difference at all. So first off, let's find our center. The center is going to be the point that's directly in the middle of 5, 0, negative 5, 0, which will be 0, 0, or the point that's directly in between your two co-vertices, which is still going to be 0, 0. So now let's find our A value and our B value. Your A value is the distance from a center to your vertices, which will be 5. The B value is the distance from your center to your co-vertices, which will be 2. Now the next thing we just need to find out, is this a horizontal or is this a vertical ellipse? And your vertices here are going to lie on that transverse axis that I was talking about. So the center is going to be at 0, 0, and 5, 0 and negative 5, 0 are to the right and to the left. So therefore, your hyperbola looks like this. So therefore, it's going to be a horizontal transverse. So since, again, you can think if your vertices are left or right of the center, then it's going to be horizontal. If your vertices are up and down of the center, then it's going to be a vertical. So therefore, since it's horizontal, we're going to list our x stuff first. And since we've not translated anywhere, we don't have an x plus or x minus, we're just going to have plain old x squared. Same thing with the y stuff, it's listed second. So your formula again is, in this case, since it's horizontal, is x squared over a squared minus y squared over b squared. And since we have a and b, we can just plug those in, is equal to 1. Number 4, your vertices are located at 4, 8, and 4, negative 8. So therefore, the center, to find it, we're going to find the midpoint of these two or the midpoint of these two, either way. It's probably going to be easier, since they're positive values, to just use these two. Add your x's, divide by 2 gives you 4. Add your y's, divide by 2 gives you 0. So therefore, there's your center. I like to determine whether it's a horizontal or vertical next, but we can go ahead and find our A value and our B value, which, by the way, this C stands for center. That's not our C value. Our A value is the distance from the center to a vertex, so that would be 8. Our B value is the distance from the center to a co-vertex, which is 3. So now we've got all of our pieces. We just need to find out, is this a horizontal or is it vertical? Look at your center and look where your vertices are located. It's located above and below. So that's going to be a vertical. So your y stuff will be listed first. Let's put our transformations with our y's and with our x's. So it's going to be y stuff over a squared minus x stuff over b squared is equal to 1. Our x has been translated to 4, so we're going to put a minus 4 with our x to move it to the 4. Our y value has not been translated at all, so we don't need anything with our y's. So it's going to be plain y squared. So now we have y squared over a squared, which will be 64, minus x squared over b squared, which will be 9, is equal to 1. There's your formula. Number 5. Step number 1, let's find our center. The point that's in between these, we can add, I'm going to put it over here. Add your x's. 12 negative 2 gives you 10. Divided by 2 gives you 5. Add your y's. Negative 6 and negative 6 is negative 12. Divided by 2 is negative 6. Again, you could have done the exact same thing with your co-vertices. Next up, let's find our a's and b's. Your a value is the distance from the center to a vertex, and that's going to be from 5 to 12. That's a distance of 7. Your b value is the distance from the center to a covertex, and you can use either one. The distance from negative 6 to 0 is going to be a distance of 6. So there you go. Next up, your vertices. Here's your center. Your vertices are to the right and to the left of that center. So therefore, this is going to be a horizontal ellipse, or excuse me, a horizontal hyperbola. And again, you can see the methods are actually just alike what we did before. So since it is horizontal, our x stuff is listed first. So we've got x stuff squared over a squared minus y stuff squared over b squared is equal to 1. Here's your translation. We're going to translate it right 5, so x minus 5, and up 6, so y plus 6. Make sure you put this with the x, this with the y, because again, sometimes they're flip-flopped. Our x stuff squared needs to be over a squared, which would be 49. Our y stuff squared needs to be over b squared, which would be 36. So there's your hyperbola. Vertices on the next one, we need a center to begin with. The center is going to be, again, the midpoint between our vertices, so negative 9 and negative 9 divided by 2. 3 and negative 5 is negative 2 divided by 2 is negative 1. So therefore, there's my center. My a value and my b value is the distance from the center, the a value is, to the vertex. And you can use either vertex. That's going to be a distance of 4. The b value is the distance from here to my co-vertices. It's probably easier to look at this one. That's a distance of 10. My vertices, negative 9, 3, and negative 9, negative 5 are above and below. So therefore, this will be a vertical. So your y stuff will be listed first. There's your formula. We translated it. My center was left 9. So you got to be careful. Put that on the x, plus 9 to move it left 9. Down 1 will be a plus 1 on the y. Your a value goes under the first term. So since a is 4, a squared is 16, goes under the first term. Since your b is 10, then b squared, which is 100, goes under your second term. There is your hyperbola. Number 7. Now we're dealing with a foci, so we are going to have to use the relationship between a squared, b squared, and c squared, which again is simply the Pythagorean theorem when you're dealing with hyperbolas. We're going to use that to find our b value in this case. The center is going to be the middle of these 2 points, the midpoint. So therefore, the center is going to be 0, because this is 0, 3, and 0, negative 3. So therefore, the point right between them will be 0, 0. You can go ahead and find out if it's a horizontal or vertical by looking and seeing where is the vertices in relation to the center. 0, 3, and 0, negative 3 is above and below this center, so therefore it'd be a vertical. So therefore your y stuff will be listed first. And notice that I didn't put them in parentheses because this has not been translated. It's going to be at the 0, 0, the center is, so therefore we don't need a y plus or a y minus. So therefore now we've got to find our a, b, and c values. Our a value is the distance from the center to the vertex, which is 3. Our b value, we don't know. However, we do have a c value. C value is the distance from the center to a focus. Plus and minus root 73, the distance from 0 to root 73 is root 73. So therefore, we're going to use those 2 values. Come over here and plug them in. 3 squared plus b squared is equal to the square root of 73 squared. Now, reminder that when you square a square root, it simply removes the root. So therefore, let's take the root away. Solve that. B squared is subtract 9. That'll be B squared is 64, so B would have to be 8. And now that you have A and B, A squared goes under the first term, B squared goes under the second term, so there's your hyperbola. Number 8, the center is the midpoint of these 2 points. So 2, 5, and 6, 5, add the 2 and 6, divide by 2 gives you 4, and add the 5s, divide by 2 gives you 5. Now your A, B, and C value for your formula. You have an A value here. The distance from here to your center would be 2. The distance from here to your center would be 3, and we don't have our B yet. We're going to use A squared plus B squared is equal to C squared to find our B value. A is 2, so therefore we have 4 plus B squared equals 9. Move the 4 over, gives you B squared is 5, so therefore B would have to be the square root of 5. Next up, let's find out, is this a horizontal or vertical? This point, if you were to plot 2, 5 versus 4, 5, this point is to the left because 2, you only went over 2 here, you went over 4 here. So this is to the left and this is to the right, so therefore this is horizontal. Since it's horizontal, the x stuff will be first. So x stuff squared over a squared minus y stuff squared over b squared is equal to 1. We translated it to 4, 5, so that would be right 4, up 5. Our a squared goes under this term. Our b squared, when you square the square root of 5, it turns into 5, goes under this term. Number 9. The center of these 2 points will be your center. So therefore, add your x's, gives you negative 6 divided by 2. Add your y's, negative 18 divided by 2. It stays the same. Let's see. Let's find our a, b, and c value. A value is the distance from the center to a vertex. That'd be a distance of 4. Since we have the foci, the distance from the foci to the center would be our C value, so that would be a distance of 5. To figure out what our B value is, again, we're going to use Pythagorean theorem. A squared plus B squared equals C squared gives me 16 plus B squared equals 25. Subtract 16 gives me B squared is 9. So therefore B would have to be 3. That is a 3, 4, 5. Now, let's see, is it a horizontal or vertical? The vertices, 1, negative 9 versus negative 3, negative 9 is going to be, let's see, negative 3, negative 9. 1, negative 9 is going to be to the right, and this is to the left, so therefore this is a horizontal. So therefore the x stuff comes first. Here you have x stuff squared over a squared minus y stuff squared over b squared is equal to 1. Now let's just fill everything in. We got to move it right 3 and or left 3 down 9. So we're going to do a plus 3 to move it left 3. We're going to do a plus 9 to move it down 9. A squared goes under your first term. B squared goes under your second term, and that's it. Number 10, the center is between these 2 points. Add your x's, divide by 2, stays the same. Add your y's, divide by 2, gives you 8 divided by 2, which is 4. There's your center, the A value, B value, and in this case, the C value. A value is the distance from your vertices to the center, which is going to be 6. Your C value is the distance from here to your center. And notice that they kind of gave you the distance because the 3 stays the same, the 4 is the same, but you added 2 root 10 and you subtracted 2 root 10, so obviously 2 root 10 was the distance. Okay. So we're going to use that along with our Pythagorean theorem to find our b value. A squared plus b squared is c squared. Let's plug it in. A squared is 36 plus b squared is equal to square this, a reminder, to square a c, we're going to square 2. We're going to square a square root. Square 2 gives you 4. When you square the square root of 10, it gives you 10. So that's 4 times 10, which would be 40. Let's subtract our 36, gives us b squared is 4, so therefore b would have to be 2. Next up, is it horizontal or is it vertical? 3, -2, and 3, 10. The x's stay the same. The y values change, so therefore it has to be above and below, so this will be a vertical. So let's list our y stuff first. So y stuff squared over a squared minus x stuff squared over b squared is equal to 1. Our transformation would be right 3, up 4, so that would be right 3 on the x, up 4 on the y. Don't get them mixed up. Make sure you put your left and right on the x, your up and down on the y. The a squared goes under the first term. The b squared goes under the second term. There you go. There's your hyperbola. Number 11. Here they give you covertices instead of vertices. It really doesn't matter. We're just going to work it the same way. Just remember the distance to the covertices would be b versus a. And here they will give you a c value. So let's find our center first. We'll put it right here. The center is going to be the midpoint. Let's add our x's. For the covertices, the foci, it's all symmetrical, so you can do it on any of the points. Add your x's gives you -2, divided by 2 gives you -1. Add your y's divided by 2, it'll stay the same. So there's your center, your a value, your b value, and your c. We don't have a because we don't have the vertices, but we do have covertices, which give us b. The distance from the center to the covertices, which is 6, is your b value. The distance from the center to the foci is going to be your c values, which in this case will be 10. Come over to the side, a squared plus b squared is equal to c squared. Subtract 36, oops, gives you a squared is 64, so a must be 8. There you go. So therefore, next up, let's determine what type of hyperbola we have. The foci are on the, not the conjugate axis, the transverse axis. And we always said if the transverse axis is vertical, it's a vertical. If the transverse axis is horizontal, it's horizontal. So since these foci are on that transverse axis, this foci are above and below the center. So therefore, this would be a vertical hyperbola. So therefore, the y stuff will be first. Y stuff squared over a squared minus x stuff squared over b squared is equal to 1. We're going to move it left 1 and down 3. There's your transformations, always backwards. Your a squared goes under your first term, your b squared goes under your second term, and you are done. Number 12. First off, your center. Let me come down below it so we can keep that in screen. The center is going to be the midpoint between here and here. The -2, add them, divided by 2 stays the same. 0 and 10, add them, divided by 2 gives you 5. So there's your center. Your a, b, and c value for your formula. You don't have your a value, but you do have your b value. Looking at this would be a distance of 5 away. The c value, notice what they've done. They took your -2 and they added root 51 and they subtracted root 51. So therefore, it would be root 51 away. When you add root 51 to -2 or you subtract it, that tells you what the distance was. A squared plus b squared equals c squared. A squared plus b squared equals, when you square a square root, it gets rid of the square root. Subtract 25 gives you a squared is 36, or actually 26, excuse me. So therefore, a is going to be the square root of 26. So next up, let's figure out, is this going to be horizontal or is it going to be vertical? Again, do not look at your covertices. Your covertices are located on the conjugate axis, not the transverse. Your foci are located on that transverse axis. So we took our x value and we went to the right and we went to the left to find our foci. So therefore, this would be a horizontal, since right and left would be horizontal of it. So we're going to list our x stuff first. X stuff over a squared minus the y stuff squared over b squared is equal to 1. To move it to our center, which was left 2 and up 5, we're going to do plus 2 on the x, and we're going to do minus 5 on the y. The a squared, which is root 26, a squared would be 26, goes under your first term. b squared goes under your second term, and there is your hyperbola.